Today we're going to take a look at numbering systems and how to convert between those numbering systems. Let's get right into it.
Let's start with what we know. We grew up in the decimal system, so we know that when we count in decimal, start counting with 0, 1, 2, 3, 8, 9. I'm out of digits. At this point, you have to start counting over again with a 0 and then push a 1 into the next column. So we already know that in the decimal system, this column is the ones. When you push this 1 over in the next column, it's worth 10. And the next column is worth 100. And the next column is worth 1,000, 10,000, etc., etc. So each one of these is 10 to the 0th power, 10 to the 1st power, 10 to the 2nd power, 10 to the 3rd power, 10 to the 4th power.
0 counts as a digit. So as we look through these numbering systems, notice that every one of them starts with 0, and that is one of the digits. So if we're going through decimal, you count from 0 to 9, but that's actually 10 separate digits.
So now let's take a look at binary. The word binary means 2. Decimal means 10, so you notice that each one of these are multiplied, or actually the exponent to the 10th power. This is going to be everything to the 2nd power. This is 2 to the 0th power is 1s, 2 to the 1st power is 2s, 2 to the 2nd power is 4, 2 to the 3rd power is 8, 2 to the 4th power is 16, 2 to the 5th power is 32, and that goes on and on and on and on. So as we're counting in binary, you start counting with 0, 1, and those are my 2 digits. Base 2 system, I'm out of digits, I have to start over again. So just like in the decimal system, start over, but push a 1 into the next column. So now if I keep counting 0, 1, I'm out of digits, I have to put zeros and push a 1 into the next column. So now there's a 1 times 4 is 4, plus 0 plus 0. So 100 in binary is equal to 4 in decimal. Now let's take a look at octal. Octal means 8, so we're in a base 8 numbering system. So 8 to the 0th power is 1s. So it multiplies by itself each time. So 8 to the 1st power is 8. 8 squared is 64. 8 cubed is the same thing as 8 times 64, which is 512. So in the octal system, you start counting just like the others. 0, 1, 2, 3, 4, 5, 6, 7. I'm out of digits. These are your 8 digits for octal counting. At this point, you have to start over and push a 1 into the next column, just like the others. So 10 in octal is 1 times 8, 0 times 1, that's 8. 10 octal is the same as 8 decimal. Finally, let's go with the hexadecimal system. Hex means 6. Decimal means 10, and so if you put 6 and 10 together, you have base 16 counting system. So the first column is 1s, that's 16 to the 0th power. 16 to the 1st power is 16. 16 squared. 16 squared is 256. 16 cubed is 4,096. And then that just goes on and on. Each time stepping up, 16 cubed, 16 to the 4th, 16 to the 5th, etc. So just like all the others, you start counting with 0, 1, 2, 8, 9. And now we continue on with A, which would represent 10 in decimal, B, C, D, E, F. So B is worth 11, C is worth 12, D is 13, E is 14, F is 15, and that's the end of our 16 digits. And now you have to start over. with the 0 and push a 1 into the next column. So 1 times 16 is 16 plus 0. 10 in hexadecimal is worth 16 in the decimal system. Hey, I could use some help converting numbers. I need some help converting numbering systems. Anybody? Can you help me? Guess not. Okay, so there are two ways to convert between numbering systems. Let's start with one way is, let's say we have the number 45 base 10, that's decimal, and we want to change it into binary. The first step would be to take the 45 and divide it by 2 because 2 is binary. So I can look at this and say that 22 goes in there twice. 22, subtract that, get 1. So your remainder is 1. This is the least significant bit. So I'm going to write a 1 on the right hand side and then start writing more numbers as they get more significant moving to the left. So I still have 22, and if I divide 22 by 2, that answer is 11. So the remainder is 0. So I write a 0 in here. Now I have 11 divided by 2, and that's going to be 5. 2 times 5 is 10, and that is a remainder of 1. So I need to write my 1 up here. Whoops. 1. There. Okay, I have 5 left over, so we take the 5 divided by 2, and that's going to be 2. 2 times 2 is 4. The remainder is 1. So we have another 1 up here. And then finally, 2 divided by 2 is 1. It's 2. The remainder is 0. And then we have nothing left except this 1 on top, so we have to count that one. So there's this 0 goes here, and then that 1. Okay, so did that work? Let's see. Remember the value of your columns. This is the 1s, 2s, 4s, 8s, 16, 32. So let's add these up. I have a 1 here, so 1 times 32 is 32. 1 times 8, 40. 1 times 4 is 44. Nothing there. 1 times 1, 45. There we go. We did it. So I want to show you a different way of converting from decimal to binary. Let's use the same number, 45. But this time I'm going to set up my columns. I've got 1s, 2s, 4s, 8s, 16, 32, 64. What I can do here is fill in the blanks based on the number I'm trying to convert. 45 is smaller than 64, so I can't use this one. That could be a 0. 45 is bigger than 32, so I can use this one. So there's 32. 16 plus 32 is 48. 48's too big, that won't work. So I have to put a 0 in here. 32 plus 8 will work. 32 plus 8 is 40. So now we're up to 40. I can put a 1 in there and add 4. There's 44. So I just need one more. 2 won't work. I have to put a 0. The 1 makes this 45. So now you have two different methods of converting from decimal to binary. And then we just converted this back by following this pattern and adding these numbers. Notice that these two are the same thing. Let's do this again. We'll take the number 45, base 10, but now we're going to go to octal. So I've got to take 45, and this time I'm going to divide by 8 for octal. And 8 goes into 45 5 times. 5 times 8 is 40, and your remainder is 5. So 5 is your least significant bit, and then we're going to keep filling in our numbers this way. So now I have this 5 on top, divided by 8 is 0. Your remainder is 5, and that's it. We're done. So 55 in octal is the same as 45 in base 10. Well, let's double check that and make sure that's right. In the octal numbering system, you have the 1s, 8s, 64s, and then that's as far as we need to go with this. We said 55, right? 5 there and 5 there. So 5 times 8 is 40, plus 5 times 1 is 5, 45. And this is the other way that we did before. I can go in here with my numbering system and say 1s, 8s, 64s, 512s, etc. And then fill in these numbers. 45 is smaller than 64, so none of these are going to work. 5 times 8 is 40 is as big as I can go. So I put a 5 in there, and that's 40. And then I need 5 more, so I put 5 in there. So 5 times 1 is 5, and that's 45. Let's do one more. Again, 45 base 10, but this time we're going to go to hexadecimal. So I've got to take 45, this time divided by 16. 16 can only go in there twice. 2 times 16 is 2. 45 minus 32 is 13. So the remainder, 13. Now wait a minute. Remember that hexadecimal numbering system. A is 10, B is 11, C is 12, D is 13, E is 14, F is 15. So actually our remainder is D. So I'm going to write D in the least significant bit, meaning the ones column, and then start counting this way. So we have 2 left over. 2 divided by 16 is 0, and the remainder then is 2. So 2D in hexadecimal is the same as 45 in hexadecimal. Let's double check just to make sure. You have your 1s, 16s, 256, and 4096. So D is 13. 2 times 16 is 32. 32 plus 13 is 45. There you go.
Well, there's my take on numbering systems. I hope this was helpful to you, and if you have any questions, of course, leave me a comment below, and I'll do my best to answer them for you. Have a good one.